We're working on lesson 30, which is on repeating decimals. Recall from yesterday's lesson that if you have a ratio and you want to write the ratio as a decimal, you're going to divide. So you would divide 3 by 4, and you're going to have to add a 0 because you have a remainder. And this ends at 7/5, so 3/4 is 0.75, which you know. This is called a terminating decimal simply because it ends. Well, today we need to talk about repeating decimals. 1/6 is an example of a repeating decimal. If you say 10 divided by 6, you would get 1 with a remainder of 4. Add a 0. 6 goes into 40 6 times. And when you subtract, you're going to see that we're going to start repeating a remainder of 4. So the number that you're going to put up is going to constantly be a 6. So the 6 is going to repeat. When we write this, we are going to write it as 0.16 repeating. The digit that repeats is called the repetend. The line that you put over the digit or digits that repeat is called the vinculum. We need to discuss what might happen if you have a mixed number with a fraction and they ask you to write that as a decimal. Initially, you can just ignore the whole number and work with the fraction. So you would divide 1 by 3. And this is another one that you know the answer to already. It's 0.3 repeating. So 1/3 is 0.3 repeating. However, you have to take into account that you had a whole number. So you just replace the 0 with your whole number once you have figured it out, and it would be 2.3 repeating. This is just something interesting that I found, and it's the pattern for the sevenths. The one very interesting thing is you would have to go out 7 to 8 places to find out that 1/7 is a repeating decimal, because it repeats after 6 digits, which is unusual. So the actual way you would write this would be 0.142857 with the vinculum over all 6 of those digits because they all repeat in that pattern. But where it becomes interesting for you math nerds is 2/7 is also repeating after 6 places. It just starts in a different section of the repeat, but it uses the same 6 numbers in the same order. 3/7 starts with the 4 of the repeating pattern, 4/7 with the 5, and so on. So if you want to impress your friends, write out 1/7 as a repeating decimal. Okay, when you're converting rational numbers to decimals, there are 3 possible outcomes. First of all, your outcome can be an integer. So if you had -3 divided by 1, your answer would be -3. If you had 6 divided by 2, your answer would be 3, an integer. You can have a terminating decimal. For instance, 1/2 is 0.5. It ends, it terminates. Or you can have a non-terminating decimal with repeating digits or decimals, such as 1/3, which is 0.3 repeating. There's also non-terminating and non-repeating decimals, and they are called irrational numbers. This is what I want you to watch out for. Sometimes you think that any number that's a square root is going to be irrational, but that's wrong, because if it's a perfect square like 4, the square root of 4 is 2. You might think that just because this number is a decimal, you're not going to be able to find a square root, but you are, because the square root of 2.25 is 1.5. This is a very important one to learn because it is used a lot when you're doing dilations and scale factors. So that 1.5 squared is 2.25. If you look at the square root of 22.5, you're using the exact same digits as 2.25, but there's no way to find a perfect square for 22.5. No number times itself is 22.5, so the square root of 22.5 would be an irrational number. So what's going to happen if you have a problem like find 5/6 of $12.47? Well, you could say, I don't want to work with a fraction, so I want to convert 5/6 to a decimal. So you would divide 5 by 6, and you would see that it becomes a repeating decimal rather quickly. And it would be 0.83 repeating. You cannot multiply with the repeating decimals, so you have to round. And the way you would round is you would look, if you were rounding to 2 places for money, you would look at the third place out, the thousandths place, because it's less than 5, 0.83 repeating would approximately be equal to 0.83. So if you take $12.47 and multiply it by 0.83, it comes out to 10.3501. But you're working with money, so you need to round to the nearest hundredth. There's a 0 after it, so this number rounds to $10.35. Suppose you wanted to work with the fraction. Well, then you would take $12.47, you would multiply it by 5. That would come out to 62.35, which you would have to divide by 6, and you get $10.39. Once again, that's a rounded answer. And you have to say to yourself, which one is more accurate? Because there's a 4-cent difference between those two numbers. And $10.39 is more accurate than $10.35 because you rounded twice in this problem. You rounded once to get your original decimal, and then you rounded again to find your answer. In the problem with fractions, you only rounded when you divided 62.35 by 5, or by 6. So this is a much more accurate answer. So rounding decimals introduces error into your calculations. There are 2 sets of problems at the end of this lesson. There are 5 calculator problems, A through E. I would like you to do those. You need to get used to seeing how your calculator works in these situations. And then practice set A through J. And the last thing is just a review. We've done this several times. If you have a repeating decimal, how do you put it in order from least to greatest? We've talked about needing to have the same number of decimal places and to compare numbers. So you can see that 30 is the smallest number of these 3, so 0.3 would go first. What do you do when you come to 0.3 repeating and 0.33? Well, the first 2 places are the same, so add a third place, add a thousandths place, and now you can see that 33 hundredths is less than 0.3 repeating, so you would put 0.33 and then 0.3 repeating. So you need to be careful about your repeating decimals and how they're going to be written. Good luck. We'll talk to you tomorrow.